Welcome to example 2. During a freestyle competition, a swimmer performs a crawl stroke at a pool 50 meters long, and as she swims at racing speed to one end, then when she comes back, she goes at twice the length of time to come back. We're asked to find the average velocity for the first leg there and the second leg back, and then what is the average velocity for the entire swim. So one of the first things I normally do here is I like to start off by writing what is given in the problem. And I also like to draw a picture as well. So you could put the given information in the picture, or you may want to do a picture and then put the given separately over on the side. I could see that in the first leg that she swims from here to here, we're going to call that delta x sub 1. And that displacement is going to be 50 meters. Now, I guess we should define where our coordinate system is. So let's lay down an axis in here. So there's my origin here set here, and there's my positive x-axis. So therefore, this distance is 50 meters. So when she goes for her first leg, that's going to be a positive 50 meters. And the time frame for the first leg is going to be 24 seconds. So we're trying to find in part A what is the velocity of her during the first leg, and we also want to find the velocity during the second leg. Okay, so in our next step here, we're going to solve the problem. We have to think of the appropriate formula. Well, you've only learned really one equation at this point. The average velocity, v sub 1, is equal to the displacement, delta x1, put vector signs, divided by the time interval, delta t, 1. And then we're going to substitute in. She's moved a total displacement of 50 meters along the positive x-axis. I'll put a plus sign here. And then the time interval was 24 seconds. This will give us a velocity of 2.08 meters per second. And this is positive in the forward direction. Okay, what about when she returns? So what's the displacement? Well, we have a displacement that is now going in the opposite direction because she's going this way now. So now rather than going positive 50 meters, she is now going to be moving negative 50 meters. And the time is not 24 seconds. Delta T2 is now going to be 24 seconds times, I think it's going to be twice as much. Yeah, she swims to cover but takes twice that time to swim. So that's going to be multiplied by 2. So we have 48 seconds. Her average velocity when she returns is now negative 1.04 meters per second. Okay, let's move on to part B. What is the average velocity for the entire swim? So we'll write V and then average here. That's going to be the displacement for the entire swim divided by the time. Now, guess what do you think is the most common mistake that people are going to make? They're thinking, well, I got the first velocity. I've got the second velocity. Can't I just take the two numbers and average them? Well, that doesn't quite work because, first of all, they're not in the same time intervals. If they're both 24 seconds as well, then yeah, sure, you could do the averages, but they're not of equal time, so you can't take, they're not like kind of like equally weighted per se. So you can't quite do that. So you have to think, she started here at the origin, she went all the way out to here, but then she came back to where she started. So what was her displacement? You got it, 0. And the total time, well, it doesn't really matter. Sure, you can put it in, 72 seconds, but really, her average velocity is 0. So I suppose those of you guys who are on the track team running around the track all day long, and then if you come back to where you start, you can tell your track coach, my average velocity was 0. Was your average speed that? No. Your average speed would be the total distance. So we could do a little bit on the side here. The average speed, if we talk about the speed, that would be the total distance that she traveled divided by the total time. So just this is an aside here. If you're talking about the speed, that would be at 100 meters divided by 72 seconds, which gives you an answer of 1.39 meters per second. But that's not what we were asking. This is just like an aside. We weren't asking about what the average speed is. We were asking for the average velocity. So know the difference between the two of them. That's it for this example.